they're like, the first thing you should remember is interference. Now, although interference looks like a bad word, but in physics, interference can both be constructive and it can also be destructive. Constructive in the sense that suppose you have a wave like this, and there is another wave which is like this, and then if they meet at a point, right, because they're exactly the same, so we can say that these waves are like in phase, which I told you from the previous chapter, we know it should be like 0 degrees, 360 degrees, 720 degree, etc. Right? So then the result of this is that anything that you do constructive in life even gives you a bigger reward, like this. So what has happened is that these two waves have just met, and their amplitudes have combined together to form a bigger amplitude. Like for example, if this has an amplitude of A, this has also an amplitude of A. So, oh crap, I don't like this. Okay. Just a second. Yeah. I think I made it too big, but never mind. Let me make it bigger like this. So basically, the amplitude, let's suppose the amplitude of this is A and the amplitude of this is also A. So after like combining constructively, their new amplitude is gonna be A plus A, which is 2A. Is that clear? Aman, Hamad, you guys have any questions here? Right? Now, when you talk about being destructive in that sense, then destructive interference means that you have one wave that looks like this, and you have another wave which is basically exactly opposite. Which means that when the crest of this wave is forming, the trough of the other one is there, right? Like that. So when they meet together, like if I say these two, they are anti-phase. Right now, like they have a, a difference of 180 degrees. So what I'm saying is it could be like any difference, doesn't really matter, right? So 180, 540, etc. Let me write a few things more. It could be any difference, but the thing is that now when they meet together, they are just going to cancel out each other. So destructive behavior and destructive interference in anything in your life and in waves is not good, right? So that means it is going to cancel it out. And if it cancels out, even if the amplitude of this one was A, the amplitude of this one was A, the amplitude of this is going to be 0 because it just cancels it out. Because amplitude of this one is, at the same point it is minus A because of the fact that if this is A, positive, then downward it is displacement to negative A. Do you guys understand this, Aisha? All right. I hope that this is cleared. Aman, you have a question?
No, sir, it's clear.
Okay, good. So then we can talk about the principle of superposition. Now, the principle of superposition basically states that when two or more waves meet when two or more waves meet at a point, the resultant displacement of individual waves no, the resultant displacement at that point, sorry. The resultant displacement at that point is equal to the sum, and that's the keyword, right? Sum of the displacements of individual waves at that point, like that. Okay, so it's just the same thing, like in above examples, just the same, right? Because they meet at a point where they had, suppose in the first one they had amplitude of A, the other one was also A. So when they met, their resultant displacement would be the sum of their individual displacement. So it's 2A. And when the amplitude was A and minus A, then it's 0. So if it was 2A, if one had 2A amplitude, one had just A. So the wave that would have formed after meeting would be 3A then. Do you guys understand what I'm saying? Alright. So you can write this down, please. And we'll see. Okay, now that's good. So, one of the things, like one of the results of principal superposition or interference, is basically the production of stationary waves. And we're gonna talk about stationary waves in this chapter a lot. Let's look at them. So stationary waves are basically a result of interference between two waves of I equal frequency equal amplitude traveling along same line, and number 4 in opposite direction. So I've just broken it up for you so that you guys can remember this. But remember that whenever two waves that interfere, which have the same frequency, same amplitude, just traveling along the same line, but just in the opposite direction, this basically creates. Okay? Okay. So what I mean by this is, suppose that we have a fixed end and we move the fixed end, we can move the fixed end like this. Like we can move the wire, that's a rope, something like that. So when you move it one and twice, basically the fixed end creates a wave. Like the rope creates a wave that is moving now to this side, say outward. And when this fixed, like from the fixed end, it reflects. So after reflection, it will become like this, and now the same wave is moving inwards. And now we move, like we're still continuing to move it, so another wave is created, and which is moving like outwards. So the result of all of this is that when they meet, because they have like same equal frequency, equal amplitude, and traveling along the same line, so when they meet, they're gonna create sort of a pattern like this, where now they're only moving up and down and they're stationary there. Is it clear, everyone? Like that. Okay, please write this down. Okay. You guys can hear me, right? Javeria, Aman?
Yes, sir.
Okay, thank God. I told you I moved to a new place, right? So I don't know if everything is working. Do you guys need to respond faster, Okay. All right. So now, Acha, okay. So now, so basically then, now let's look at how when a stationary wave is formed, what are its properties. So for a stationary wave, I would like to tell you so it's like it basically looks like this. Okay, sometimes I make terrible mistakes while drawing it. Try not to make those like that. So, well, okay, in fact, let me redo this. This is like very, very small, high frequency. I want something relaxed like this. Okay. All right. So, these places where you see ends like these, where they're meeting, these are called nodes. Nodes are written as N, that's the symbol we use. And the other places, like this one, the center where they're not meeting, that's where the vibration is maximum. These are called antinodes. So this will be A, this will be A, and so on, right? Now, what you guys need to understand is that if we are asked what exactly is a node, so we say that a point with zero frequency is a node, and with no energy. Well, that's understood, but if you write it, that's very nice. And if they say what exactly is an antinode, so antinode would be a point with maximum amplitude and 2 max energy, because that's where it's vibrating the most, like that, up and down. That's fine. Okay, if you have any questions, please let me know.
No, sir.
Okay, you can write it down, please. It's pretty standard, something new for you to learn, but that's nice thing, I guess, something new to learn. Okay, now so speaking of this, then what you guys need to understand is that when you draw, like if you see a stationary wave which is vibrating like up and down like this point, like we can say, okay, this point is the node, this is the node, and of course this is the node. To identify, it's very important, right? And this is an antinode and this is also an antinode. But the thing is that if you look at the difference, right, if you see that, let me just point it out using the highlighter. So if you see this part, this whole part basically makes up one wave. All right, so which means that from the crest to the trough, basically this distance between the node, antinode to antinode, is basically equal to half lambda, as you can see. It's half wavelength. And that is also true for node to node, which is also half lambda. As you can see, it's like halfway. So what we've learned just now is antinode to antinode or node to node, basically it's equal to half lambda. That's one way. And if you look at this portion, like this one, so you might realize that basically this is like a quarter of lambda, which is basically quarter wave. So we can say this is a quarter of lambda, which means node to an antinode or antinode to a node, this distance is quarter of lambda, and that's what you guys need to remember. This is the most important thing that I have taught you today. Like that. Okay, please write this down. Okay. Okay. Now, so in 10 minutes, please, like in few minutes, I would like you to rejoin. So now, what exactly is the difference between a progressive wave and a stationary wave? I'm just gonna explain it using first the like graphically, and then I'll explain it. ये दरवाज़ा बाहर का बंद कर दो। आवाज़ आई जा रही। Okay, so in progressive waves, basically, I just need a little bit of your time, basically, to draw this. And, okay. And at least 5 needs to be there. Okay. Okay. So I'm going to say this is when time was 0. This was when time was a quarter of time period. This was time when it became half time period. Then time of 3/40, and then time when it was t. Okay. Now, just a second, please, to adjust this. Okay. Now, okay, so in the progressive wave, suppose that at time t is equal to 0, it looked like this, okay? And in a stationary wave, at time t is equal to 0, it basically looked like this, right? Like that. So these points, like after like a quarter wave, oh my god. So after quarter time period, basically it would look like this then. If this is just one pulse, okay, look like this. Because it has moved this much a quarter wave ahead, and then after the next quarter, which is half, it would look like this. And in the next half, it looks like this. And in the last half, it looks like as if it has moved one whole wavelength ahead from the first one, as you can see. So it seems that the energy is being transferred from one point to another. But what about stationary wave then? So in stationary wave, it would be different in the sense that it's going to show you static positions. So let's see how. So right now, this is, I'm just gonna mark like through a different color though. No, this color is not good. Okay, so node, this is antinode, this is node, this is antinode, this is node, antinode, and node. So now, after like this portion is gonna move down. This portion is gonna move up, and this one down as well. So it would look like a straight line. And the node is still here, antinode is here, node is here, antinode, node, antinode, and node. Now, the antinodes then will continue to move down, up, down, where they were moving. And now the wave basically looks like this. Where, if you check it out, the nodes are still there, antinodes are there, node, antinode, node, antinode, node. Now, because it has gone to the extreme position, so in the third quarter, it will now come back, because the antinode part is just vibrating, not the nodes. And again, it would look like a straight line. The thing is, as you can see, that none of it basically seems to be moving. And then this is now moving upwards, this is downwards, upwards. So again, after one whole cycle, the whole time period, it basically looks like oh my god. Basically, it looks like exactly the way it was when it had started vibrating. So as you can see, that in a stationary wave, the wave basically is not transferring any energy at all. The nodes are there, they're not moving, only antinodes are moving. Yes.
Sir, why is it not moving at 3/40?
Sorry, come again? Come again.
Sir, I'm saying why is it constant at 3/4 time?
3/4 is not constant. It's still moving. But it's this portion, right? This part of the wave, which you see here, basically moves up. This goes down, this moves up. So at this instant, it seems like it's a straight line. But it's moving.
Okay.
Do you understand? But even if you look at it, only these portions like this one throughout the whole wave, right? Only the antinodes seem to be moving and not the other way around. You see? only them are moving. Even when they are here, they're moving. It's just that at that instance, it is going to show you this. Understood? Okay. Okay. So I hope you guys understand what I'm saying right now, and I hope it's not too hard for you to get this right. So between stationary and progressive, I just wanted to clarify that it's like one is moving and one is not, and then so on. So one stationary wave means that it's staying where it is. It's not transferring any energy. Progressive wave means that it is transferring energy from one point to another, and that's the beauty of it, right? So I guess everything is clear now. If you have any questions, please ask. Otherwise, we have to close the class now. Okay.